Assalamualaikum. Today we're gonna present about centrifugal pump. First of all, let me introduce myself and my team members. My name is Aina Fatia binti Aziz with ID BAA2723 and my group members are Fikriah Nohaja binti Azmi with ID AA19081 and Muhammad Hazwan bin Muhammad Hamdan with ID AA19075. We choose a centrifugal pump that is used in industry in Shah Alam, Selangor, Malaysia. Centrifugal pumps are devices that are used to transport fluid by the conversion of rotational kinetic energy to the hydrodynamic energy of the fluid flow. It is suitable for liquid with a relatively low viscosity that are poor in such as water. The connection of centrifugal pump in series and parallel system exists in removing groundwater, which is a common problem in the mining process. Next, I pass to other presenter.
I will present about the concept of centrifugal pump. In the square-shaped form of the pump, fluid enters the pump axially through the eye of the impeller that is low pressure area which rotates at high speed. When the impeller and blades rotate, they transfer momentum to incoming fluid. The fluid accelerates radially outward from the pump casing and a vacuum is created at the impeller's eye, then continuously draws more fluid into the pumps. As the fluid's velocity increases, its kinetic energy increases. Fluid of high kinetic energy is forced out of the impeller area and enters the volute. In the volute, the fluid flows through a continuously increasing cross-sectional area. The impeller blades are usually backward curved, but they are also radial and forward curved blade design. The output pressure slightly changes depending on the design used. The blades may be open or closed. The diffuser also may be fitted with fixed vanes to help guide the flow towards the exit. The energy transferred to the liquid corresponds to the velocity at the edge of the impeller. The faster the impeller revolves or the bigger the impeller is, the higher will the velocity head be. A centrifugal pump is a rotodynamic pump in which a shaft-mounted impeller rotates within the pump casing, then accelerating the pump fluid radially outward. Therefore, the two main components of a centrifugal pump are the rotating element, consisting of an impeller on a shaft and the stationary casing. These components can come in a range of different types, and centrifugal pumps come in various different configurations, depending on the requirements of the application for which the pump is required. First component is impellers. The impeller's rotary motion imparts energy to the pump liquid in the form of velocity, some of which is then converted to pressure within the impeller passage. Inducers. These are basically axial flow impellers with extended vanes. They act as an inline booster for the main impeller when suction conditions are poor. Casing. The conversion of velocity head to pressure head in the pump casing either occurs via a volute casing or by a stationary diffuser. Diffuser. A diffuser fits inside the pump casing and directs the flow smoothly into the discharge pipe or to the next impeller in the case of a multi-stage pump. The diffuses multiple vanes from radially diverging water passage around the periphery of the impeller and recover much of the total head. Shaft and bearings. The shaft transmits the driving torque to the impeller. With the support of bearings, the shaft also locates the impeller within the casing. Single stage pump with double inlet impeller. While a pump of this type should theoretically be in complete axial balance, slight casting difference can cause slight difference in the flow pattern of each impeller entry, resulting in residual axial thrust. A ball bearing of the combined radial thrust type is used to take this thrust. Multi-stage pump with balance drum. The area of the balance drum is similar to the impeller unbalanced area but slightly undersized to ensure a residual unbalanced loop to keep the shaft in tension. The axial load is taken by a thrust bearing. The thrust bearing can be of the ball type, but a tightening pad thrust bearing may be used for high speed or high thrust load application. Axial thrust. The most common way to combat axial thrust involves the use of a hydraulically balanced impeller with a back ring and balanced holes, which reduce the pressure at the rear of the impeller by allowing leakage through to the suction side. Another method is to employ impeller rear vanes radial thrust. The magnitude of radial thrust is determined by the total head, impeller diameter, and impeller width. Advantage of centrifugal pump. Firstly, centrifugal pumps work well with large volume of liquid transfer. Centrifugal pumps are commonly used to transport water, chemicals, and light fuels because they are well suited for transferring large volumes of low viscosity liquids. One downside is that the impeller must be covered in liquid at all times to work as designed, so centrifugal pumps may not work as effectively for viscous or inconsistent liquids. However, to overcome this vortex, an open impellers can be used to move certain types of solid debris in liquid without clogging, while chopper impellers can reduce the size of solid to ensure smooth operation. Secondly, centrifugal pumps are simple in design. Even any type of pump can be made complex with some additional features. The basic design of a centrifugal pump is very simple. They do not require valves or pistons, and also the moving parts are minimal, so they can be created using a variety of materials to suit their purpose, from plastic tube to stainless steel or bronze. Maintenance will often be minimal and relatively straightforward when compared to other pump types. Thirdly, centrifugal pumps are comparatively compact. The design of pump is simple. It also takes up a relatively small amount of space. This is one of the reasons many will choose a centrifugal water pump in both residential and industrial settings.
Centrifugal pumps are commonly used for pumping water, solvents, organics, oil, acid, base, and any thin liquids in both industrial, agriculture, and domestic applications. In fact, there is a design of centrifugal pump suitable for virtually any application involving low viscosity fluids. There are 8 types of centrifugal pump. The first one is can motor pump, magnetic drive pump, chopper or grinder pump, circulator pump, multi-stage pump, cryogenic pump, thrash pump, and the last one is slurry pump. A centrifugal pump operates through the transfer of rotational energy from one or more driven rotors, called impellers. The action of the impeller increases the fluid velocity and pressure and directs it toward the pump outlet. With its simple design, the centrifugal pump is well understood and easy to operate and maintain. The impeller of a centrifugal pump can be of 3 basic types, which is open impeller, semi-open impeller, and closed impeller. Centrifugal pumps also used to transport fluids by the conversion of rotational kinetic energy to the hydrodynamic energy of the fluid flow. The rotational energy typically comes from an engine or electric motor. There are a subclass of dynamic axisymmetric work-absorbing turbo machinery. The fluid enters the pump impeller along or near to the rotating axis and is accelerated by the impeller flowing radially outward into a diffuser or volute chamber, which is casing, from which it exits. Common use include water, sewage, agriculture, petroleum, and petrochemical pumping. Centrifugal pumps are often chosen for their high flow capabilities, abrasive solution compatibility, mixing potential, as well as their relatively simple engineering. A centrifugal fan is commonly used to implement an air handling unit or vacuum cleaner. The reverse function of the centrifugal pump is a water turbine converting potential energy of water pressure into mechanical rotational energy. That's all from us. Thank you.